There are 3 videos for section 5.7. This is the first one. There will be 2 examples here. In this section, we are solving radical equations. So we are solving equations that have that radical symbol in them. This video has 2 examples. And the first one is right here. It's the square root of x plus 3 plus 4 equals 10. First thing, what we're going to do here is when we can, we like to start things off by isolating the radical if we can. So if I look, how can I get that radical alone on the railroad track? So I'm going to start subtracting both sides by 4. So I get a root of x plus 3 on the left equals 6 on the right. Now that I've isolated that root on the left-hand side of the equation, I'm ready to go and try to think about how can I get rid of that root? What would you do to both sides of an equation to get rid of a square root? Well, you'd square both sides. So we'd end up here, a square root and an exponent of 2 cancel each other out. You're left with an x plus 3. And then on the right-hand side of the equation, 6 squared is 36. So now it's pretty simple to finish to solve for x. Subtract 3 from both sides, x equals 33. Now, what we have to do here is check what's called what we call extraneous solutions. The radical is kind of tricky sometimes because it sometimes introduces answers that aren't actually answers, kind of some false answers. So when you are solving equations that have radicals, you always have to check your answers. I know that's not the favorite thing for students to do, but it is worth your time to do so. All you do is rewrite your equation, but every time you see an x, we're going to put, in this case, a 33 instead. And then what I'm going to do is simplify that left-hand side and see if the left side and the right side match. So underneath that radical, 33 plus 3 is 36. PEMDAS would say I square root before I add, so square root of 36 is 6. And then 6 plus 4 equals 10. So I end up with a true statement. It's true to say that 10 equals 10, so then I believe that x equals 33 is a proper solution. The one step students get hung up with is right here, is they say, isn't the square root of 36 a plus or minus 6? Well, what we're going to do here when we're checking our answers, we're only going to use the positive square root. If you can remember back in chapter 3, when we dealt with our function families, the square root family had a domain when x was greater than or equal to 0. Our domain was restricted to positive x values. So that's why when we're checking, we will only take the positive root. So right here, we didn't write plus or minus 6, we just wrote plus 6. Let's try another example. This one, we're calling it medium. It's just a little bit trickier, but really not so bad. I think you're going to handle it just fine. Step 1, you're trying to isolate the radical, and what's nice is the radical is already isolated. It's the only thing on the left side of your equation. So I can jump right into, well, how do you get rid of a radical? You square both sides. So on the left, this radical, since everything's underneath the radical and the exponent of 2 cancel each other out. So I'm left with a 2x plus 3 on the left with an x squared on the right. Now this x squared right here should ring a bell for you that we actually have a parabola. We're in the quadratic function, so we need to factor. So in order to factor, to solve for x, I need to get this in standard form. I need to get everything on the same side of the equation, and I really like to do it in a way so that a value, which in this case is 1, stays positive. So my standard form, I've got x squared minus 2x minus 3 equals 0. So now that it's time to factor, so it'll be simple factoring because a equals 1. The x squared splits to x and x. And now my factors of 3 are really just 3 times 1. So how can a 3 and a 1 multiply to a -3 and add to a -2. Well, that will happen when the 1 is positive and the 3 is negative, because a -3 times 1 is a -3, and a -3 plus 1 is a -2. So that's factored. Now I need to solve. So I'm going to apply that zero product property and set x minus 3 equal to 0 and x plus 1 equals to 0. And then when I solve for x, I have two answers of x equals 3 and x equals -1. But I am going to have to check both of them to make sure that these are both okay answers, that I didn't introduce a false answer, which sometimes happens with radicals. So what we're going to do is just take a minute and check our answers. We're going to check when x equals 3, and we're going to check when x equals -1. So I'm going to write this, I'm going to write this equation, but every time I see an x, I'm going to put in a 3 instead. And then I'll do it again, where every time I see an x, I'll put in a -1. All right? So then work to simplify that left side and see if you end up with a true statement. So over here, underneath that radical, 2 times 3 is 6, and then 6 plus 3 is 9, and the square root of 9 is 3. I end up with a true statement of 3 equals 3. So I believe that x equals 3 is an answer that works. Please remember from this, from this step to this step, you only take the positive. It's not a plus or minus 3. You're going to just take that positive version. All right, now over here on that second equation, 2 times -1 is a -2. -2 plus 3 is 1. Square root of 1 is 1. Remember, we're not writing plus or minus 1 because we only can have the positive version. And so it looks like I don't have a true statement here. 1 does not equal -1. So that means x equals -1 is not a correct answer. So x equals 3 will be our only answer here.